Namaste children, today you learn about remaining law in law of chemical combination, that means law of reciprocal proportions and Gay-Lussac law, and also you learn about what is quantum number and what is its classification and different notation of quantum number. Have you ready to see the video?
Hello students, have you observed any day how the volume of the gases, reactants and products relate to each other in a chemical reaction? The answer to this question you will find in my present video. So in this video, we are going to discuss about the remaining two laws of chemical combination, the laws of reciprocal proportion and the Gay-Lussac's law of combining volumes. So let's start. Now let's understand the fourth law, that is the law of reciprocal proportions. Okay, so let's understand about it. So which states that if two elements B and C they react with the same mass of the third element A, the ratio in which they do so will be the same or simple multiple if B and C reacts with each other. Okay, so to understand the statement, let's take an example. Okay, it can be better understood by taking an example, right? So here we are taking two elements, one is B and C. These two elements, they are reacting with the same mass of the third element. So A is the third element, so B is reacting with A and C is reacting with A, and the mass of A that is reacting with both B and C is same. Okay, so the ratio in which these two elements they combine with the fixed mass of other element, the ratio in which they do so will be the same or simple multiple if B and C reacts with each other. Say the B and C are reacting with each other and they are forming a product. Okay, so let's say this is a mass of B and this is the mass of C and this is the mass of A, that is fixed. So the ratio of these two, that is mass of B by mass of C, this ratio it should be either equal to this ratio. Here B and C they are combining with each other, right? So say suppose this is the mass of B, say this is capital MB and this is capital MC. Okay, so these two ratios either they should be equal or one should be integral multiple of other. So this is what the law of reciprocal proportion says. Okay, so let's see, let's understand this by taking an example. Let's take that sodium is one element and chlorine is other element, and sodium is reacting with hydrogen and chlorine is reacting with the same amount of hydrogen. Okay, so here this is B, this is C and this is A. Okay, so the mass of hydrogen is same here. Na and H react and they form sodium hydride, and HCl it form HCl. Okay, so the amount of hydrogen is same in both the compounds. So here this ratio, here sodium it is 23, the chlorine it is 35.5, right? So this much amount of sodium and this much amount of chlorine is reacting with 1 gram of hydrogen. Okay, so let's see the reaction between sodium and chlorine. Sodium and chlorine they react and they form NaCl, right? So one atom of sodium and one atom of chlorine will react. So this ratio is how much? Sodium is 23, the chlorine is 35.5. So this ratio is 23 by 35.5 and this ratio is 23 by 35.5. So these two ratios are equal, right? That's what I said. These two ratios either they should be equal or one should be integral multiple of other. Okay, so this is what the law of reciprocal proportions is. Okay, so let's move to the next law, that is the last law, that is the Gay-Lussac's law of combining volumes. Gay-Lussac's law of combining volumes, which state that at a given temperature and pressure, the volumes of all gaseous reactants and products they bear a simple whole number ratio to each other. So this is what the Gay-Lussac's law is. Let's take an example. Let's understand this law also with an example. So here the hydrogen is reacting with oxygen and is forming water, right? So here if you see the 2 moles, it is 1 mole getting 2 moles, right? So you can say 2 volumes will react with one volume of oxygen and it will give you two volumes of H2O. Okay, so all these volumes are measured at the same temperature and pressure. So the volumes of all gases, all these are gases, all gases, reactants and products, they bear a simple whole number ratio to each other. So if you take this one, it bears a simple ratio to other reactant, 2:1. Here it is 2:2. Okay, so each one will bear a simple whole number ratio to other. Okay, so hydrogen, it bears a simple whole number ratio to oxygen and water. Here this is oxygen 1:2, and the oxygen, it bears 1:2 with H2O. Okay, so this is the volume of the reactants as well as products, they bear a simple whole number ratio. Similarly, if you see here, this is one volume is reacting with one volume and we are getting two volumes, right? So this is 1:1:2. It's a simple whole number ratio. Okay, so this is what the Gay-Lussac's law of combining volume states. Okay, so till now we discussed about the five laws of chemical combination. That is, we discussed about law of conservation of mass, law of definite proportion and law of multiple proportions in our previous part. So in this part we discussed about law of reciprocal proportions and the law of Gay-Lussac's law of combining volumes. Okay, now let's discuss a problem. Discuss a problem on the law of chemical combinations. Okay, two gaseous samples were analyzed. One contained 1.2 grams of carbon and 3.2 grams of oxygen. The other contained 27.3% of carbon and 72.7% of oxygen. So the above data is in accordance with which law? So this is a question from JEE 2012. So how we can do this question? See, we have two samples, right? One is containing carbon and oxygen, other is also containing carbon and oxygen. So they are containing the same elements. Let's see the proportion. This is 1.2 grams, right? So carbon is 1.2 grams and oxygen is 3.2 grams. This is 27.3% and this is 72.7%. Okay, so let's see the percentage composition of carbon. It is 1.2 by 1.2 plus 3.2. This is 1.2 by how much will get 4.4, and similarly oxygen will get 3.2 by 4.4. This value comes out to be how much? 4.311, and this is 4.8 So 3 by 11 you will get 27.3% you will get, and here it is you will get 72.7%. So the two samples are containing the same elements in the same proportion. So this is in accordance with which law? That law of definite proportions, right? So this data is in accordance with the law of definite proportions. So option P is the correct one. Okay. So students, in this part we discussed about the two laws of chemical combination. One is the law of reciprocal proportions and second one is the Gay-Lussac's law of combining volumes. Hope you get the answer to my question which I asked at the starting of this particular part.
The quantum model of atoms says electrons are smeared out according to their energy levels, which helps determine an element's spot in the table. Quantum numbers are used to describe energy levels. The principal quantum number, or n, indicates the energy shell, or how far from the nucleus an electron is, and how high its energy is. The outer shells have the highest energy, and the farther out you get, the more electrons you can fit. As a rule, atoms always fill up their low energy shells first and work their way out. Energy shells are divided into subshells called the angular momentum quantum number, labeled as L, which are further divided into subshells called the magnetic quantum number, labeled as ML. Together, quantum numbers N, L, and ML specify an electron's orbital, another word for its location in the electron cloud.
From this video, you can definitely know about the law of reciprocal proportion and also learn about Gay-Lussac law. Okay, then quantum number. Quantum number is nothing but it's a number which designates which the electrons located and what is the electron located orbital containing shape and also spin of the electrons. Okay, இப்போ இந்த குவாண்டம் நம்பருங்கிறது என்ன அப்படின்னா ஒரு நம்பர். இதை எது டிசிக்னேட் பண்ணுது அப்படின்னா ஒரு ஆர்பிட் ஒரு ஆட்டம் பார்த்திங்க அப்படின்னா அந்த ஆட்டத்தில் எலக்ட்ரான் சர்க்குலர் பாத்தில் ரிவால்வ் ஆகும். ஸோ அந்த சர்க்குலர் பாத்துக்கு பேர் தான் என்ன அப்படின்னா ஆர்பிட். அந்த ஆர்பிட்டில் அந்த எலக்ட்ரானை எங்கே நம்ம சீப் பண்ணக்கூடிய அந்த ப்ராபபிலிட்டி அதிகமாக இருக்கோ that is called orbital. Orbital is nothing but it's a three-dimensional space around the nucleus where the probability of finding the electron is maximum. Okay, so what is the orbital shape? Okay, and what is the orientation of electron along the orbital in a x-axis or y-axis or z-axis, and what is the spin of the electron? These informations are gained from the quantum number. The first one is principal quantum number. It is designated by n. It gives information about size and energy of the orbit. Okay, if number of orbit increase, also the energy increases. Then second quantum number is azimuthal quantum number. It is designated as L. It gives information about shape of the orbital. What is meant by orbital? The probability of finding the electron is maximum. Okay, the orbital is classified into 4 types. That means s orbital, p orbital, d orbital and f orbital. The shape of the s orbital is spherical and shape of the p orbital is dumbbell and shape of the d orbital is double dumbbell and f orbital is cloverleaf shape. Okay, number magnetic quantum number. It is designated by m. Okay, the electrons which orientation. Okay, x axis la orient ஆகுதா, y axis la orient ஆகுதா, z axis la orient ஆகுதா, okay, ஒரு magnetic field la வைக்கும் பொழுது. So this type of information is gained from magnetic quantum number. And spin quantum number. Electrons not only revolve around the nucleus, it also revolves itself. So electron என்ன பண்ணும் அப்படின்னா நியூக்ளியஸை மட்டும் ரொட்டேட் பண்ணாது, அது தன்னைத்தானே என்ன பண்ணிக்கும் அப்படின்னா ரொட்டேட் பண்ணிக்கும். ஸோ ஸ்பின் குவாண்டம் நம்பர் கிவ் இன்ஃபர்மேஷன் அபவுட் ஸ்பின் ஆஃப் த எலக்ட்ரான். இட் ஹேவிங் 2 வேல்யூ plus of and minus of. If the electron revolve in a clockwise direction, it is having value plus of. If it revolve in a anti-clockwise direction, it is having minus of. Okay, thank you children. I hope you understand what is law of chemical combination and also quantum number. Okay, thank you children.